Hello students, today we are going to understand the examples of projectile motion and I will make you solve 4 different cases as we discussed in our last video. Today the first example that you see on screen here is a projectile which is fired with an initial velocity of 36.6 meters per second at an angle of 42.2 degrees. We are going to try finding out here the horizontal range, the maximum height and the time of flight. Let's start with the first situation and we will try determining the horizontal range. But the question here arises that if you have to determine horizontal range, there may be some other elements that you may have to first find out, and that may help us to find out the different possibilities of this projectile motion situation. So if I say time of flight and if I say the maximum height. Through this example, you will also understand that what should be found out in the order so that you can find the rest of the information. So there may be this situation that I may have to find the horizontal range first, but without knowing the time of flight, it may not be possible, which helps you understand that we may have to find the time of flight first in order to get the maximum height as well as horizontal range. And in order to understand that, we need to split the data into 2 dimensions as discussed earlier. So all we are going to do is, we are going to write the information about the different motions of the object in the x direction as well as in the y direction, following the SWOT trend. So let's see the distance in the x direction, or the displacement in the x direction is denoted by s subscript x. As we see, the velocity is at an angle due to which we can resolve it into 2 components, and therefore the velocity in the x direction will be u cos theta. Since acceleration in the x direction is always 0, the velocity in the x direction finally will also remain the same, which is u cos theta. Now as you see here, that as per the given information that we have in the question, we have the value of u and we have the value of theta, which means that we can determine ux and vx very easily. Also we have the value of acceleration. But in order to determine the displacement in the x direction or the horizontal range, we need to know the value of time, without which it will not be possible for us to determine the horizontal range. And therefore, this cannot be the first question that will be assessed in your examinations. So the first question therefore comes in the examination is to determine the time of flight. And now let us understand how can we determine this value. As we know that the time of flight in this situation is going to be the time taken to go up the motion plus time taken to come down. Since we deal with all situations considering air resistance to be negligible, the time taken to go up and the time taken to come down is going to be the same. And therefore, we can say that the time taken for completing the entire journey is 2 times the time taken to just go up. Now as we see that the time taken to cover A to B is equal to the time taken to cover half the horizontal range, we will only use the vertical components to determine the value of time, since this is the common factor between the 2 components. So what do we know in the vertical direction? Let's try figuring out. So in the vertical direction, the value of u, which is the initial velocity, is going to be u sine theta. At max height, the velocity in the y direction becomes 0, so this remains 0. And since the projectile motion is a motion controlled by the force of gravity, the acceleration is going to be minus g. And now we just have to determine the value of time here. Based on this set of information and the use of SWOT equations, which is v equal to u plus at, the value of time can be determined. Let's see how would that happen. So the value of v is 0, the value of u, which is 36.6 times sine 42.2 is your initial velocity, plus the acceleration value is minus g times time taken to just go up, that is from A to B. If you make the time the subject of your equation, the equation is 36.6 sine 42.2, the whole divided by g. Now since we know all the values in this set, we can determine the value of t by just taking it as 2 times the time taken for it to go from A to B, which can be substituted right here. And once you know the time of flight for the entire journey, you will also know the time value in the x direction. And in a further video, we will now understand how to calculate the horizontal range using the value of time of flight.